applying the theory of relative gravity and the delta phenomenon to the Big Bang. In the context of the theory of relative gravity and the delta phenomenon, we can reframe the Big Bang not as a singular, one-time event that marks the beginning of the universe, but rather as a cyclical process within a larger polymorphic framework. This approach challenges traditional cosmology by suggesting that the Big Bang could be just one iteration in a cycle of universe creation, transformation, and evolution. Here's how the delta phenomenon can be applied to the Big Bang. 1. The Big Bang as an iterative cycle. In the delta phenomenon model, the universe can be seen as undergoing cyclical iterations where each cycle represents a state of existence in a continuous and evolving system. The Big Bang could be viewed as a recurrent event in a sequence of iterations. The explosion of the Big Bang would represent one iteration of the universe's existence, where an immense amount of energy, space, and time suddenly emerges from a singularity. However, instead of being the beginning of everything, it would be a moment in an infinite series of cosmic cycles. Each cycle contains elements of polymorphism, where entities, such as galaxies, stars, and particles, evolve and transform over time, inheriting properties from previous cycles and passing on these properties in their own time. Thus, the Big Bang is part of an ongoing process where the universe is constantly being reborn in different forms while retaining the essence of prior cycles. 2. The Big Bang and the delta phenomenon. The delta phenomenon suggests that entities evolve through polymorphic transformations, where they exhibit unique personifications across different states, but all share the underlying properties of the same phenomenon. If we apply this to the Big Bang, we can propose that the Big Bang represents an instance of transformation within the broader continuum of universal cycles. This transformation can be broken down into several key principles from the delta phenomenon. Principle 1. Basis of dimension in a body. The Big Bang would not represent a sudden appearance of dimension or space, but rather a shift from one-dimensional state to another, in which the universe expands from a singularity into a multidimensional reality. The expansion of the universe as seen in the Big Bang could be understood as the manifestation of dimension in a new state of existence, inheriting the properties from the previous iteration of the universe. Principle 2. Prior and future iterations. The current state of the universe as manifested by the Big Bang cannot be fully understood without acknowledging its past iterations, prior Big Bang events, and its future cycles, the eventual collapse or transformation into new forms of existence. Each Big Bang might be one iteration in a cycle of cosmic rebirths, where the universe contracts, reaches a singularity, and then expands again. The idea of prior and future iterations highlights the continuity of existence across cosmic cycles, even though the specific physical forms change with each iteration. Principle 3. Family of entities and unique personifications. The Big Bang represents one of many iterations in the life of the universe. In each cycle, entities such as galaxies, stars, and matter undergo transformation, maintaining a unique personification of their properties, yet all sharing a common origin in the cyclical nature of the delta phenomenon. Just as a single entity can undergo polymorphic transformations, the universe itself cycles through different forms and dimensions, retaining its inherited properties while evolving over time. Principle 4. Parallelism and symmetry. Despite the apparent uniqueness of each Big Bang event, there is symmetry in the recurrence of these events. This symmetry implies that even as the universe undergoes transformation from one cycle to the next, there are underlying patterns of reference that tie the cycles together. The Big Bang might look different in each iteration due to different states of matter or energy, but the fundamental nature of transformation, the expansion from a singularity, the formation of matter and space, and the eventual evolution toward a new state remains consistent across cycles. This symmetry is rooted in the delta phenomenon, which allows for the continued transformation of entities and forces while preserving certain invariant properties. 3. The Big Bang is a part of a larger polymorphic universe. In this framework, the Big Bang is not an isolated or singular event. It is a moment in a much broader polymorphic system in which the universe undergoes repeated cycles of creation, transformation, and dissolution. These cycles are interconnected and driven by the continuous inheritance of properties from previous iterations. Inheritance of properties. The properties of the universe in the current Big Bang event are inherited from previous cycles. Matter, energy, space, and forces do not emerge from nothing, but are recycled in a cosmic process that ensures continuity across time and space. Each cycle contributes to the formation of new systems and structures within the universe, carrying forward the foundational characteristics of the delta phenomenon. Polymorphism of forces. The four fundamental forces, gravity, electromagnetism, and the strong and weak nuclear forces, are expressed in the Big Bang as a unified force, undergoing transformation as they evolve through different states of the universe. The forces are viewed as having a relative relationship to each other within their context in time and space, a reflection of their polymorphism within the universe's larger cyclical process. 4. The Big Bang and the continuity of time. In the delta phenomenon, time is not a linear progression, but a cyclical phenomenon, where each iteration of the universe contributes to the continuity of time. In this view, the Big Bang marks the beginning of a new cycle in the flow of time, but it is not the first instance of time itself. Time, like matter and energy, is inherited and transformed across each iteration. Spatial time and reference frames. Time within the universe is seen as relative to the specific reference frames of entities. The Big Bang could be interpreted as a shift in reference frames, where the universe begins anew in a new context, with each entity evolving its own perception of time based on its state in the universe. The expansion of the universe after the Big Bang can be thought of as the opening of new reference frames, each with its own unique progression of time. Conclusion: the Big Bang as an iterative event. In the context of the theory of relative gravity and the delta phenomenon, the Big Bang is not a singular origin, but one iteration in a cyclical universe. Each cycle of the universe is a transformation, where properties of energy, matter, and time evolve and are inherited across iterations. The delta phenomenon allows for a view of the Big Bang as part of an ongoing, eternal process of universal creation, where the universe's laws and forces are not fixed but subject to polymorphic transformation, retaining essential properties while evolving across cosmic cycles. In summary, the delta phenomenon and theory of relative gravity can reframe the Big Bang as part of a cyclical process rather than a singular event. In this view, the Big Bang is one phase in an infinite cycle of cosmic creation, transformation, and rebirth, with each iteration inheriting properties from the last. The universe's forces, dimensions, and entities evolve through polymorphic transformations, keeping some core characteristics while expressing them in unique ways across cycles. Time is not linear, but cyclical, and the Big Bang marks the start of a new reference frame within an ongoing sequence of iterations. The symmetry and continuity of these cycles suggest a deeper cosmic pattern, where the universe constantly redefines itself while conserving fundamental properties. This approach ties the Big Bang to a broader, eternal model of universal evolution.